Hi, today we'll be solving the Majun Series 2018 Pure Mathematics Paper 11. Find the first three terms in the expansion in ascending powers of x of 1 minus 2x to the power of 5. To do this, you need the terms x to the power of 0, x to the power of 1, and x to the power of 2. You'll use 5c0 plus 5c1 plus 5c2. If you compute this in your calculator, you will get 1 minus 10x plus 40x squared. And this will be your final answer. Let's move on to the second. Given that the coefficient of x squared in the expansion of is 12, find the value of the constant a. Since we have 1 plus 8x plus 2x squared in the first parenthesis, we will use the answers we have earlier and transfer them below. 1 plus 8x plus 2x squared will be multiplied by the answer we got earlier, 1 minus 10x plus 40x squared. Now you will calculate the coefficient of x squared, so you will need to multiply 1 with this, ax with this, and 2x squared with 1. You will get 40x squared plus 2x squared minus 10ax squared. Since you know that the coefficient is 12, we will go ahead and erase all the x squares and equate them to 12. You will get 12 minus 42. So a will be negative 30 divided by negative 10, which is 3. A point is moving along the curve y equals to 2x plus 5 over x in such a way that the x coordinate is increasing at a constant rate of 0.02 units per second. Find the rate of change of the y coordinate when x is equal to 1. From the question, we know that dx over dt is 0.02 unit per second. So in order to find dy over dt, we will need to multiply dy over dx, which is the derivative, with dx over dt. So we have to find the derivative first. The derivative is 2 minus 5x to the power of negative 2. So when x is equal to 1, you will get negative 3. Go ahead and input that in the equation, so you will get dy over dt is equal to negative 3 multiplied by 0.02, which is equal to 0.06 unit per second. A curve is such that the derivative is shown. The point 1, 1 lies on the curve. Find the coordinates of the point at which the curve intersects the x-axis. So to do this question, you need to find the equation of the curve first. We'll go ahead and integrate this equation. To do this, you need to divide 12 by 2, which is the number here, and by -2 plus 1, so by -1. You will get -6. 2x plus 1, you will add 1 to the power of -2, so it will be -1 plus c. Since we know that the point 1, 1 lies on the curve, we can use that coordinate to find c. We'll go ahead and input 1 for x and 1 for y. You will get -6 divided by 3 plus c equals to 1. So you will get c equals to 3. So your equation will be y is equal to -6 over 2x plus 1 plus 3. Since we want to know the point at which the curve intersects the x-axis, we know that the y is 0. So it will be 0 is equal to -6 divided by 2x plus 1 plus 3. We'll go ahead and subtract 3 from both sides. So we will get -3 is equal to -6 2x plus 1. We'll switch up here. So 2x plus 1 is equal to -6 divided by -3, which is 2. So we'll just go ahead and write that as 2. So you have 2 minus 1 divided by 2, which is half. When x is half, you have to find y. So you will use the original equation here to find y. So y is equal to -6 divided by 2 multiplied by half plus 1 plus 3 is equal to 0. So your point will be half and 0. For question 4, you have to prove the identity of a certain equation. What you want to do here is to expand the equation on the left. After doing so, you will need to group the ones that have the same component. For example, I want to group these together because they have cosine. Now we'll group the rest together. Next, I will factorize cosine. And for the last two, I will factorize sine. Recall that sine square plus cosine square is equal to 1. So sine is equal to 1 minus cosine, and cosine is 1 minus sine square. So we'll go ahead and change these two into cosine. and you will get which is equal to that. For the next question, we will just substitute the left side of the equation with what we got earlier, which is sine cube plus cosine cube is equal to 3 cosine cube theta, which is what we see here. We will go ahead and subtract both sides with cosine cube, so we will get sine cube is equal to 2 cos cube theta. We'll divide both sides with cosine cube, so we get sine cube theta divided by cosine cube theta is equal to 2. We know that sine theta divided by cosine theta is equal to tangent theta. So we will go ahead and use that in our equation here. We'll add the cube is equal to 2. We will go ahead and cube root the whole equation, and we'll get tangent theta is equal to the cube root of 2. Go ahead and compute that in your calculator, and you will get 51.6 degree. Since this tangent is positive, we have another value, which is the sum of 180 degrees and the answer we got. You will get 231.6 degrees, which is still within the boundary there. To find the equation of AC, you will need to find the gradient first. So the gradient of AC is equal to y2 minus y1 divided by x2 minus x1. We get half, negative half. Since OB is perpendicular to AC, we know that the gradient of AC multiplied by the gradient of OB is equal to negative 1. So the gradient of OB is equal to negative 1 divided by negative half. We will get 2. Since the line OB passes through the origin, we will use the coordinates of the origin to find the equation of OB. So y minus 0 is equal to, the gradient we got is 2, in parentheses x minus 0. This is the same as y is equal to 2x. We'll use the coordinates of A to find the equation of AC. So y minus 4, which is the y coordinate, the gradient in parentheses x minus 0. This is the same as negative x half plus 4. So this is your equation for OB and your equation for AC. We will use x as the x coordinate of B and y for the y coordinate of B. Looking back, we know that OA is equal to AB since they are symmetrical. We also know that OC is equal to BC since they are symmetrical as well. Now we'll go ahead and use their lengths to find the coordinates of B. We also know that the length of OA is 4, given by the y coordinate of A, and we know that the length of OC is 8, given by the x coordinate of C. Now we will go ahead and write that down. OA is equal to AB. We know earlier that OA is equal to 4, and we'll find the length of AB with the formula. Y2, which is B, the y coordinate of B, minus Y1, which is the y coordinate of A, and is 4, square plus x coordinate of B minus x coordinate of A, which is 0. You can go ahead and remove the square root by squaring both sides, so we will get 16 is equal to y minus 4 to the power of 2 plus x squared. 16 is equal to, we will expand this, y squared minus 8y plus 16 plus x squared. We'll remove 16. So x squared is equal to 8y minus y squared. Now we will go ahead and find OC is equal to BC. We know that OC is equal to 8 from the x coordinate of C. And we will compute that. BC like we did earlier. Now we'll remove the square roots by squaring both sides. So we get 64 is equal to y squared plus 64 minus 16x plus x squared. We'll remove 64 and we will make y the subject of the formula. So y squared is equal to 16x minus x squared. Now we have two equations we can use to find the b coordinate. Now we will substitute the x here with the x equation here. So y squared is equal to 16 the square root of 8y minus y squared minus 8y y squared. We'll go ahead and calculate that. I'm not going to do anything to this for now. Minus 8y plus y squared. We can go ahead and remove y squared from both sides. And we can add 8y to both sides. So 8y divided by 16 is equal to 8y minus y squared. And we will remove the square root by squaring the left side of the equation. Since 8 over 16 is 1 over 2, I will just write half over. Now we get y squared divided by 4 is equal to 8y minus y squared. We will multiply both sides with 4 to remove that. Y squared is equal to 32y minus 4y squared. From this, we get 5y squared is equal to 32y and y is equal to 6.4. We'll use this equation to find x. So x squared is equal to 8 multiplied by 6.4 minus 6.4 squared. And we get the square root of 10.24, which is 30. Even though we have plus minus sign here, we cannot make the answer negative because recall that in the graph, b is located in the positive side of both x and y. For number 6, what we're going to do first is to find the length of AT. This is theta. This is r. So we can use tangent. Theta is equal to AT divided by r. So AT is equal to r tangent theta. So we'll calculate the area of the triangle, right angle triangle, with half times AT, which is the height, r tangent theta, and the base, which is r. We get half r squared tangent theta. Now we'll find the area of the sector AOB. Which is half radius squared multiplied by theta. So the area of the shaded is half r squared tangent theta minus half r squared theta. To find the perimeter of the shaded region, we will need BT, AT, and AB. First, we'll find the circumference of the sector using the formula S is equal to r theta. So we'll just compute what we see. 3 times 1.2 is equal to 3.6. Then we'll find the AT. We know that AT is tangent theta multiplied by 3. So we get 7.72 centimeters. And last we'll find OT, which is the full length, before we subtract that with the radius. So OT is equal to square root of 3 squared plus 7.72 squared. This is the radius and this is AT, which is equal to 8.28 centimeters. Remember that we have to subtract OB from OT. So BT is 8.28 centimeters minus 3 centimeters, 5.28 centimeters. So the total perimeter is 5.28 centimeters plus 3 plus 7.72, which is 16.6. For question 7, to find AC, we will need to subtract OA from OC. So 3 minus 1, 2, 1 plus 3, 4. Negative 2 minus 2 is negative 4. The point M is the midpoint of AC. So we can find AM by multiplying half to AC, which is what we got earlier. 2, 4, negative 4. This will give us 1, 2, and negative 2. In order to find OM, we need to add OA and AM together. OA is what we have there. And AM is what we got earlier. This will give us 2, negative 1, 0. Now to find the unit vector in the direction of OM, we need OM to be divided by the magnitude of OM. So we'll write this literally. 2 minus 1 plus 0 divided by the square root of 2 square plus negative 1 square plus 0 square, which I will not write. And that will be equal to 1 over the square root of 5. First, we will need to find AB, which is OB minus OA. You can check both in the page before. 1, negative 1, 3, 5, minus 1, negative 3, 2. This will give us negative 2, 6, 3. We know earlier that AC is equal to 2, 4, negative 4. So we'll use the scalar product to find the angle BAC. We'll equate that to cos theta. Now we will multiply the top of each together and add that with the middle and add that with the last. Divided by $36 and $49. We get 8 over 7 times 6 equal to cos theta. So theta is equal to cos inverse of 8 over 42. And we will get 79.0 degrees. A geometric progression has a second term of 12 and a sum to infinity of 54. Find the possible values of the first term of the progression. So we know that U2 is equal to AR, which is 12. We will make A the subject of the formula, so A is equal to 12 minus. We also know that the sum to infinity, which is A over 1 minus R, is equal to 54. We will again make A the subject of the formula, so A is equal to 54 minus 54R. So 12 divided by r is equal to 54 minus 54r. We will get 54r minus 54r squared equal to 12. I will simplify this number and divide everything by 6, so I will get negative 9r squared plus 9r minus 2 is equal to 0. The roots of this equation will be negative 3r plus 1, 3r minus 2 equal to 0. So r is equal to a third and r is equal to 2/3. For r equal to a third, a is equal to 12 divided by a third, which is equal to 36. For 2/3, a will be equal to 12 divided by 2/3, which is 18. So these two are your answers. This progression is arithmetic, so I will use the formula for that. So U1 is equal to P plus Q and N, which is 1. In order to calculate the sum, I will also need the last term. The last term is N, so I will just use UN is equal to P plus QN. Now we'll go ahead and calculate the SN. Plus the last term. We will simplify this into n over 2, 2p plus q plus qn. That is your expression. Now given that S4 is 40 and S6 is 72, so find the values of p and q. For S4, we will equate that to n divided by 2, 2p plus q plus 4q equal to 40. We will simplify this into 4p plus 10q is equal to 4. For S6 is equal to 6 over 2, 2p plus q plus 6q is equal to 72. We will simplify that to 6p plus 21q equals to 72. This is your first equation earlier, and this will be your second. I will use the elimination method, but you can also use substitution method. Now I will multiply 3 here, and I will multiply 2 here to get 12p for both. So 12p plus 30q is equal to 120 for the first equation. 12p plus 42q equals to 144 for the second equation. So q will be equal to 2. Now we'll find p. We'll choose any of the equation and substitute q with 2. We get p is equal to 5. So these are your answers. For question 9, in order to find the points of intersection, you will need to equate fx with gx. So x over 2 minus 2 is equal to 4 plus x minus half of x squared. We will multiply this equation with 2 to get rid of the denominators. and we will get x minus 4 is equal to 8 plus 2x minus x squared. We will find the roots, and it's x minus 4 and x plus 3. When x is 4, you get y equals to 4 divided by 2 minus 2, which is 0. And for x equals to negative 3, you will get y equals to minus 2 equal to negative 3.5. So your points are these two. We found earlier that the x coordinates are x is equal to 4 and x is equal to 3, negative 3. So we will go ahead and draw a number line for negative 3 and 4. Let's say I want to choose a number below negative 3, so I will pick negative 4. We will use negative 4 in the equation that we got earlier, which is x squared minus x minus 12 is 0, equals to 0. This will give us 16 plus 4 minus 12, which is 8. This is a positive number, so I will go ahead and add the number positive there. Now I want to choose a number between negative 3 and 4. I will choose 0. When I substitute 0 to the equation, I will get negative 12. Negative 12 is a negative number, of course, so that will be negative. And I will choose a number above 4, let's say 5, and compute that in the equation. I will get 25 minus 5 minus 12, which is also 8. So I will go ahead and put a positive number here as well. So in order to find fx larger than gx, we can go ahead and tweak the equation here to larger than 0. Since we need larger than 0, we only accept positive numbers, so it will be x smaller than negative 3 and x larger than 4. And these are your set of values. For this question, we need to insert g to the function f. So 4 plus x minus x squared, half of x squared divided by 2 minus 2. This will give us x over 2 minus x squared over 4. Since we want to find the range of fg, we will use the derivative of the function fg. So dy over dx of this is half minus 2x over 4 equals to 0. We get half minus half of x is equal to 0. X is equal to 1. So the y-coordinate for this is half minus a quarter, which is a quarter. So we know that the point here is a quarter. So the graph can only be quarter below. It cannot be quarter above because there's nothing there. So your inequality will be fg is smaller than or equal to a quarter. Find the smallest value for k for which h has an inverse. We'll go ahead and find the derivative of the function h to find the maximum point as we did before. 1 minus x is equal to 0, so x is equal to 1. And again, this is your maximum point. So for h to have an inverse, it has to be k has to be 1, or k can be larger or equal to 1. To show that the curve has no stationary points, you have to find the derivative of the equation above. So dy over dx is equal to 3x squared minus 4x plus 5. Now we'll find the discriminant of this using b squared minus 4ac. b is negative 4, so negative 4 squared. A is 3 and c is 5. This will give us 16 minus 60, which is negative 44. Since this is smaller than 0, since the discriminant is smaller than 0, it has no stationary points. Denoting the gradient of the curve by m, find the stationary value of m and determine its nature. The gradient of the curve can also be the derivative of the curve, so m is equal to 3x squared minus 4x plus 5. To find its stationary value, we have to find the derivative of m, so dm over dx is 6x minus 4 equals to 0. So 6x is equal to 4, and x is equal to 1.5, or 2/3. Now we'll compute this to this equation to find the y coordinate, or what we call here is the m coordinate. So m will be equal to this is equal to 11 over 3. Now to find the nature, we have to find the second derivative. So d squared m minus dx squared is equal to the derivative of 6x minus 4 is 6, which is larger than 0, so it's a minimum point. Showing all necessary working, find the area of the region enclosed by the curve, the x-axis, and the line x equals to 6. In order to find the area of the region, you need to integrate the equation. Now your limits will be 6, because there's a line x equals to 6, and 0. It's 0 because the equation passes through the origin, which is 0, 0. Now write your equation as so. dx. This will give you 2/3 x to the power of 3 plus 5 over 2 x squared. Now go ahead and substitute 6 and 0 to this. So for 6, I will get minus 0, because if you substitute x with 0 here, you will get 0. Your answer is 270. So that's all for today. Don't forget to hit like and subscribe. See you next time.